Okay, we're going to take another look at that rational function that we just did all that work for, and we're going to graph it and put it all together. So I also have open the project, which is just the same graphing guidelines. I've just spaced them out a little bit more and hopefully given some direction on how to complete them. So we're going to kind of complete this project with this question as we go through it. So the first thing I need to do is graph our equation, and I've already gotten that equation graphed right here. And it does say change the color to black, so we'll do that as well. So we just hit the change thing, run gear, and then change the color. And we're going to have to modify that window eventually. This has some stuff going on down below. So it looks like if we begin changing our window, there's some stuff going on up ahead. If I start in a standard, it probably is really just y that I need to change. I can get actual y values later, but let's start with making it say -50 to 50, and we'll see how that works as a beginning place for our graph. And then as we I just picked those values because I saw that I would be able to see at least those little portions of the graph, and we'll add more to it as we go on. Okay, so the next thing that I need to do is identify the domain of interval of interest, which I've done. It's we said it was x not equal to -1 and 1. Interval of interest, that's where I didn't actually write something on paper, but the interval of interest helped me make sure I could see everything in that interval, and I want to make sure my x values don't get too big because I want to be able to see where 1 and -1 are clearly, but I did need to change the y values for that, so keep that in mind as well. Okay, now symmetry. I'm going to use a note to state symmetry. Oh, I need to use a note to do my domain or interval of interest too, so we'll do that. So we have our note that the domain is negative inf for infinity, comma -1, union, we went from -1 to 1, union, we go from 1 to infinity. For infinity is fine, or if you just want to type in inside notation, that's fine too. Okay, so that is my domain. And then the second part, now part 2, when I talk, or 3, I meant to say, when I talk about symmetry, we had declared that it had odd symmetry, so we are going to say that and then graph the appropriate function. So it has odd symmetry, which means that if I graph f of negative x, it should give me negative f of x. So if I make it negative, I'm back to the original function, right? So that's equal to the original function. So I'm going to state my claim right here. So odd symmetry because f of negative x is equal to negative f of x. You can always, of course, move that negative to the other side, which is what we showed right here as well. Negative f of negative x is equal to f of x. So that's the reason that we know we have odd symmetry, and we can see those two graphs overlap. Now I'm going to turn this one off so that I just see my original still. Okay, it does say turn the graph off, so I've done that. Okay, so I'll have my note there to prove it. Then the first derivative, do not simplify. So I'm going to type in the unsimplified version of our first derivative. So f prime was, in the unsimplified version anyway, looking back at my page for a second, so I'm just going to go ahead and type in my top line right here for the unsimplified version. Please type in that line. It's going to be a lot easier for me to verify work, which is what I'm trying to do in this stage. So my unsimplified version of the derivative is parentheses, sorry, I want to call this g of x, I believe I said. So I'm going to go back and verify, call it g of x, yes. G of x is equal to parentheses, parentheses. So I've got x squared minus 1 times 30x squared minus, I've got a 10x cubed here, times a 2x. That's all in the top, and it's divided by x, can't type today, x squared minus 1 squared. Okay, now this box over here also says to graph the derivative as well, and green, make them both green. So I'm also going to be graphing f prime of x, and we just want to show, if I make them both green like it asked, just wanted to show that they're the same, so I can turn one on, turn one off. I get the same graph for both of them, of course, and you can see it darkening as I have both graphs. Okay, so that helps me visualize that I did not make a mistake, because I can see visually what the derivative is here. I did not make a mistake in that one. Okay, so turn them both off. So those are both off. Second derivative is next. We're going to do the same thing, and we're going to make them both orange. So in the second derivative, I'm going to call it h of x. And h of x is, again, I've got my unsimplified first line right here, so I'm going to try to type in all that good stuff for our h of x function. So first of all, parentheses, parentheses, x squared minus 1 squared times 40x to the third minus 60x minus 10x to the fourth minus 30x squared times 2 times x squared minus 1 times 2x. That should close the numerator, and that's all divided by x squared minus 1 squared squared. Okay, so I'm going to make that orange first, and then I'm going to type in the second derivative and hope it lines up. Good, it did. So I'm going to make that orange also, and I can turn them on and off, and again verify that they're the same, and then turn them both off. Alright, so got a lot going on there. Okay, so got the first derivative, got the second derivative, now I have the first order critical values. Okay, so we've already found those by hand, so oops, I went too far. I just want to graph them in black and label them. Okay, so where are they? I think they're on some other page. There they are. Okay, so my first order critical values, I need to graph them as ordered pairs, but since I already have f of x defined, I can be fancy about that, I hope, and graph them comma f of x. So let's double check if we can do that. So the first ordered pair that we want is 0 comma f of 0, and if I check the label box, it's going to fill in the ordered pair for me. And then the other ordered pairs that I want are negative square root of 3, comma f of negative square root of 3. I'm not actually finding the y value right here. I'm just telling it to do it. Make Desmos do it, because when it displays in the graph, it's going to give me decimal values for them anyway, so no point getting the exact value for that. And same thing, if I copy this, I should be able to paste it, take out some extra negatives here. There we go. And then hit the label box. So the label box right here is just giving us the decimal at least coordinates though of those points. Okay, so I think it said to make all of those black and check their label boxes. So we just need to change the color on these. There should be plenty of other color coming in here later. So I've got those. And then same thing for the second order critical points. Now in our case, this one is both, so I don't really need to graph it twice, since this is both a first order and second order critical value. So I don't have anything new to graph for my second order critical values, since I had x equals 0 again as the only second order critical value, and that ordered pair is already graphed. So I have my first and second order critical values already graphed. Okay, so that's done. Got my first order critical values and second order critical values all graphed. Now we're, again, much of this started off doing by hand work. We've done that. Now we're ready to put it together on Desmos. So we're going to make a folder. Okay, as you can see, we've already got quite a long list of things going. We could probably organize that later. But I'm going to make a folder, and this folder is called Increasing / decreasing. And then in that folder, see how I'm tabbed over a little bit? I'm in the folder. In that folder, we need to use a few notes. Notes to list test intervals for the first derivative, then list intervals of increase and intervals of decrease. Okay, so this is going to be a note. You can also just hit the quotation mark to start a note. So if I'm on the keyboard, next to enter the quotation mark starts a note. So test intervals are, and I'm going to have quite a few here. So we had -infinity, comma, square root of 3. That was, first of all, the negative square root of 3. We're going to be a little bit inventive on typing these because since I'm in a note, it's not going to change them into the actual square root symbol. Then we have negative square root of 3, comma, -1. Then we have union -1 to 0, union 0 to 1, union 1 to square root of 3, union the square root of 3 to infinity, inf. Okay, those are our test intervals, and then the intervals of increase. And so again, we already stated these on paper, but since you're not going to turn your paper into me, that's why we're putting it all together here on Desmos. So the intervals of increase were -infinity to negative square root 3. And then we unioned that with square root of 3 to infinity. Okay, and then the decrease. So I forgot the note. See how it doesn't like me? There we go. I'm going to take that back off. Note. And then we go. Decreasing. On. And this was negative square root of 3, comma, -1, union with -1 to 1, unioned with the square root of 3 to infinity. All right, so not super pretty yet, but we've got some of our conclusions from paper typed in here the best I could. Okay, so I've got those. Using a note, another note, classify each first order critical value as max, min, or neither. Okay, so again, a note that said that x equals the negative square root of 3 was a, let me look back, we said max, or how about this? I'll do max at x equals negative square root of 3, min at x equals positive the square root of 3, and x equals 0 is neither. Okay, so that classifies the 3 first order critical values in terms of their types right there. Okay, using domain restrictions, graph the intervals of increase, dash them, and make them blue. Okay, so I'm increasing on those intervals. Okay, so I'm going to regraph the f of x function. But now we are going to, let me make it blue just right away so I don't forget about blue. And now I'm going to give it a domain restriction. So I want to do intervals of increase. So I'm going to do x less than negative square root of 3. I'm going to do less than or equal to. So I don't get, it doesn't really matter. Less than equal to, it doesn't really matter for this one. I think it matters more for the shading. So just less than negative square root of 3 to start with. Comma. X greater than, no, I want it between two things. What's my increase? No, it's just greater than. Okay, comma x. I was looking at the decrease in accident. So greater than square root of 3. close curly brace. Okay, so we can see how we've got this part shaded blue and this part shaded blue, and they also ask me to change the style to dashed. Alright, so if I turn projector mode on, it can sort of see the blue dashing through that black, so it just makes it a little bolder. Okay, I'm going to turn it back off though because it makes this text a little too big to fit on my screen. But I can see the blue and the black dashing together there. Alright, so that did the increase. I'm going to do the decrease in a second, but I'm already at 15 minutes. I'm going to pause this one and we'll continue the rest in the next video.